In 4.3, we're going to be looking at logarithmic properties, and there's actually 4 really nice properties that we're going to learn in this section. As we've spoken before, make sure you have your scientific calculator you plan on using on the exam as you're going through each of these problems, because now is the time to learn how your calculator works it out, so you don't have any computational areas as you go forth and do your exam. The Carthage Testing Center does have some of my calculators like this available for you when you take your exam, but the other 2 testing centers do not. Make sure you have the one that you're familiar with. You might be using a graphing calculator while you're doing your homework, but that is not allowed on an exam. So make sure you understand how to work with the scientific one, enter its buttons, and get the correct answer now. Because when it comes to the test, you cannot work this exam without a scientific calculator. I get many students, and on the side of their test, they write, "Sorry, I don't have a calculator." Well, that's unacceptable. We've been working on this since day one. So ask a friend, ask a relative, "Hey, do you have a calculator in a drawer somewhere?" And someone might have one you could borrow or use, especially to get good practice with it now before it comes to the exam. So on your calculator, we've looked at this before. You have 2 different buttons. You have this ln button and you have a log button. Both of these buttons work really well with logarithms. The ln button only does base e, and your log button will only do base 10. So we need to figure out how can we work with things of other bases, because e's and 10s are not the only ones we will work with. So that brings us to our first property. It's called the change of base property. And it allows us to take any base, we'll call it b, very general, and turn it into a base c. When we're doing this, we want to use logs that we know how to work with. And so we like to use log base 10. I'm putting the 10 here for emphasis, but typically you don't write this. Or we want to use log base e, which we write as ln. So the way you can set this up, if you're working with a log that's not base 10 or base e, is you say log of, see how the a is kind of above the b? That means you can do log of that one on top, over, see how the b is kind of lower than the a? Log of the b on the bottom. I'm emphasizing their height here on which one's higher and which one's lower, because you don't want to get these two mixed up, and so that's why I'm trying to give you a tip on how to remember that. The general form doesn't make as much sense. I know it's confusing with all the A, B's, and C's. So I'm going to do 2 examples and show you how to work with them. So the first one says evaluate using the change of base formula, and so you will have a question like this on your exam. It says use the common log change base. So I'm going to do one of them with doing the base 10, and I want to show you how to work with the ln, but at the end of the day, either of these are going to be equal to the log I'm working with. So in the first one, I'm going to say use the common log change base. So what I want to do is I want to use log base 10 in order to evaluate this. Up until this point, we would say, let's set it equal to y. Let's change this to an exponential, so it would be 4 to the y is equal to 25. And then you try to turn 4 into some power that is the same as 25, but that doesn't work out. So we have to use this change of base formula in order to evaluate this. So when you're working with log base 4 of 25, and I'm going to use the common log here, I'm going to do log of 25 divided by log of 4. See how the 25 is a little bit higher than the 4, so it's going to be on top. Now you notice I don't write base 10. If there's no base written, it's assumed base 10. So I'm going to go to my calculator. Now be careful with this. I'm going to show you the step-by-step because I want you to make sure you're getting the right numbers, but I'm going to show you in one step on how to work this. So if I do log of 25, that gives me approximately 1.398. And if I do log of 4, that gives me approximately 0.602. So if I go in my calculator, I don't want to type in these individual numbers. I do want you to understand if you're getting the right numbers, but this is rounded, so it means my final answer would be rounded. So what I want to do is I want to do log of 25, enter, there's my number. I'm going to hit divide it by, so I'm going to retain that answer in my calculator, divide it by log of 4, enter, and this gives me 2.322. Make sure you round appropriately following all instructions. I will count off for rounding errors. So again, you can see I didn't want to type it all in because if students go typing it all in, they just type it in how they want to see it. You can see that didn't give me the right answer. It's best practice to do small steps along the way to be very accurate. In grading an exam like this, I would want to see this step right here, showing me you can execute and understand the change of base, and I want to see your answer. So like 2.5 points for this, 2.5 points for this. Now let's do this again. Number 2, use the natural log change of base. So now I want to show you how it works with natural log. Say you like that button better. I'm going to set up a fraction here. I'm going to do ln of 25. You see again, it's higher up than the 4, so it's going to be higher up than the 4 over ln of 4. Now if you look at this, again, if we come over here and use our calculator and we say ln of 25, that gives me 3.219 divided by ln of 4, so I'm going to say ln of 4, that gives me 1.386. The reason I want to step this out is you can see this step is not the same. These are not the same values. But notice again, when I come over here, and again, I'm going to go piece by piece. I'm going to do the ln of 25 divided by ln of 4. So I'm going to say ln of 25, enter, divided by ln of 4, enter. It does give me the same answer, 2.322. So again, you can see the final result is the same answer. So again, what would I want it to see in exam? I would want to see that you understand the change of base property, that you can execute it to get the value of what log base 4 of 25 is. So as many students love, it's a good way to work these problems because you can use your calculator. I know you love using that. So that's our first property that we're going to cover for the day. The next property we're going to look at is the power rule. So logarithms are really nice because they do some interesting things that allow us to kind of manipulate and work with them. And one of those rules is called the power rule. What the power rule does for us is it says if I'm taking log of something with an exponent, this exponent can actually come out front and become a multiplier or a coefficient on that logarithm. You can see it went from a small exponent on the a to being a multiplier to the whole log on the front. The same is true for ln. I can bring that r out front, and that gives me r ln of a. Now sometimes these very generic forms can be confusing, so I'm going to do a few examples here with you. I'm going to do some with logs, some with ln's, and I'm going to do some putting together properties that we saw in 4.2. So let's look here. First one, log base 3 of 25. Oh, Miss Optic, why would you put that in there? Why would you put the power rule in there and you don't have a power? Well, we've been working with things in this chapter and they're all exponents. So instead of 25, I could write 5 squared. Then I see I have a power. So that I can actually bring this 2 out front and gives me 2 log base 3 of 5. So I had to really think about this and apply it and say, okay, how could I use the power rule to this? Well, I turn my 5 squared from a 25 into 5 squared and move the 2 out front. And I'm just simplifying. So some of these are going to give us nice answers. Some are just going to give us another log. Same is true here. ln of 7 cubed. So by the power rule, it says I can bring that 3 out front, and that gives me 3 ln of 7. Not too bad. Now the next ones, we're going to have to put together some of those properties, those 4 properties that we learned about in 4.2, our inverse property, one-to-one property, etc. So with this one, there's my power. I'm going to bring that out front. That gives me 1/3 log base 5 of 25. But I'm having flashbacks to this previous one, and I see that 25 actually wrote as 5 squared, so maybe let's take that approach. 1/3 log base 5 of 5 squared. Well, I got another power, so let me bring that power out front. So 2 times a 1/3 gives me 2/3 log base 5 of 5. And remember from the previous section, the inverse property says log base 5 of 5 is actually equal to 1. So it gives me 2/3 times 1, which is just 2/3. Talk about simplify. We used the power rule, we used the power rule again, we used our inverse property. So I took this crazy looking logarithm and actually simplified down to a numeric value of 2/3. Look at the next one. We're going to go back to kind of what we did in previous sections. Remember, we could take this and we can move it around. This gives me ln x to the -2. So then if I take that -2 by the power rule and pull it out front, it gives me -2 ln x. Now with that one, that's all I could do. Hope it wasn't a disappointment compared to the previous one. And then one more with just this power rule. So we've seen in other sections, when we're working with radicals, we can rewrite this radical here as a 1/3 power. So this would be log base 5 of 5 to the 1/3. Then I can take that exponent and I can bring it out front. So it gives me 1/3 log base 5 of 5. And just like we saw here by that inverse property, this would cancel to give me 1/3 times 1. So just 1/3. So you can see we cannot forget anything that we've been doing in previous sections. We can't forget our inverse property, but we can see how that power rule really is going to make life nice for us. So 2 more rules or properties I want to give you. First one is the product to sum of property of logs. And it says that if I have log of the same base and I'm adding them, I can condense that down and be log of that base and multiply what I was logging. The same is true for subtraction. If addition became multiplication, then subtraction becomes division. And so looking at this, you can see, okay, addition became multiplication, but now we only have a singular log. And subtraction became division, and we have a singular log. So a couple of the instructions you're going to see with this is you're going to see instructions like expand or condense, or you might see instructions like write as a single log. So I want to take these 2 properties, put them together what we did with the power rule, and see what we can do. Number 1, write as a single logarithm, and I'm telling you we are condensing. Again, they're going to tell you in one of 2 ways. So what we're going to do is we're just going to work left to right and see what you can figure out. So we just saw up there addition becomes multiplication. So this would be log base 3 of 5 times 8. Notice when I'm condensing it down, I'm going to a singular log, and so I'm not going to write log of 5 times log of 8. I'm going to go down to a single log of 5 times 8. Then subtraction becomes addition, and so I want to say, okay, well, now I'm going to divide by 4. So you can see now I have a singular log for that whole problem. I'm not going to write log over log. I'm not going to have logs all throughout here. I'm just going to have it once. Now these are numbers we can actually do our arithmetic with. So this gives me log base 3 of 40 over 4, which is equal to log base 3 of 10, and that would be my final answer. I'm going to work quite a few examples here in this section. This one says write as a single logarithm and condense it. Okay, so when you're working with these, we are going to have to use power rule. The first thing you want to do is you want to use your power rule to move any coefficients up. Then you want to work with your subtraction and addition, changing that to division and multiplication. So first thing I'm going to do is I'm going to bring my power rules up. So you see these coefficients in front? Let's go in reverse and let's move them up. I'm going to move them up first. They same with their single log. So this is going to give me log of x to the 1/2 plus log of x plus 1 cubed. Now we know that x to the 1/2 is really a radical, so I'm going to write that as log of square root of x plus log of x plus 1 cubed. Now I'm going to deal with this. So I can see that I have addition. It should turn into multiplication. So this would be log of the square root of x times x plus 1 cubed. Now most online homeworks you need to consider putting a large parentheses around this, and you can see even when working with a calculator, when you hit log, it automatically puts a parentheses right there. So when you go to type this in, you want to write log of a parentheses, put in everything you need, and close it. If you're working problems in the homework and you're like, I'm pretty sure I have that right, but it's marking it wrong, it might be a formatting issue. Shoot me a quick message and say, hey, I'm working on logarithmic properties homework, and I can't figure out number 5. I think it's right, but it's marking it wrong. I'd be happy to help you with that. It could just be a formatting issue. And I may just respond back with, hey, go ahead and put a parentheses in there. So let's do this one. It says write as a single log, so we're condensing it. So again, first thing you want to do is your power rule. So I see a coefficient, so I'm going to bring that up. So that gives me ln of x plus 2 squared minus ln of x. Next, I want to deal with that subtraction. Remember, subtraction becomes division. So I'm going to say ln of x plus 2 squared divided by x. And I want to make sure I put a brackets or parentheses around that, so I'm taking natural log of it all. Be careful, maybe don't write this down. Ln of x plus 2 squared, the whole thing divided by x is not equivalent. Having an ln of x is also not equivalent. So be careful with your formatting. It needs to be ln of this whole grouping. Now the next couple of problems I want to put together previous knowledge as well. This one says evaluate without a calculator by rewriting as a single log. So that means I better see some work on that exam when it says evaluate without a calculator. And it means my answer is probably going to be really nice. First thing I'm going to do is I'm going to move this power up. So this gives me log of 5 squared plus log of 4. Next I'm going to deal with that addition. So that would be log of 5 squared times 4. So go ahead and do that arithmetic. That gives me log of 5 squared is 25 times 4, so that gives me log of 100. Now it said to evaluate without a calculator, so I need to do more. I need to consider what I learned in previous sections. When it doesn't have a base, it's an assumed base 10. So let's see if we can work with that. So that would be log of base 10 of, instead of 100, say 10 squared. Okay, little steps. So I could bring that 2 out front. And by our inverse property, that's a 1. So that's 2 times 1. So that just gives me 2. So this right here, this is your power rule again. But this right here was your inverse property. So make sure you're working on the homework as you're completing these lectures and you're understanding each piece, because we're in 4.3. You've got to be aware of 4.1 and 4.2 to help you along with that. Next one says rewrite as a sum or difference of logs. So we're going to expand this one out. So in previous processes, on the previous page I just wrote, you want to handle your power rule first and then deal with your addition and subtraction. In this case, we're going to go from the bottom up. We're first going to expand it out into our subtraction and addition, and then deal with the power rule last. So first thing I want to do is I want to deal with this division bar. So this will give me ln of x to the 4th y minus ln 7. Then I want to deal with this multiplication. So it would be ln of x to the 4th times plus ln y minus ln 7. You're going to typically see me write ln's in cursive here because instead of doing a straight up and down L, which might turn into a 1N, I keep it cursive so I can recognize that it's natural log. Just creature of habit here. I've been doing that for years. And then the last step is I want to do power rule. So I'm going to bring this 4 and I want to bring it out front. So this gives me 4 ln x plus ln y minus ln 7, and I am done. So when I'm expanding it out, you can see my answer is going to have ln's throughout the entire problem. So let's do a couple more examples to finish up this section. Number 6, rewrite as a sum or difference of a log, and so I'm expanding. So they might say expand this, or they might use this wording. So again, first thing I'm going to do is I'm going to deal with the division. This would be ln of the square root of 3x minus 5 minus ln of 7. Remember radicals, I could rewrite as a 1/2 minus ln 7, and so my last step is to bring that 1/2 out front. Now, we have a property for dealing with ln being subtracted, but we don't have a property to take apart subtraction of something that's being natural logged like that. So this is your final answer. Don't overwork the problem. Don't let this confuse you into these properties we were doing here. Next one, the next two, we're going to put quite a few sections together here. This next one, evaluate without using a calculator. Okay, I'm going to show you 2 different ways to word this, and both of them are correct. And the reason I want to show you 2 different ways is I want you to see how the properties work interchangeably. So if you're working with a friend, they may work it one way and you could work it the other. So first thing I'm going to notice is I'm going to bring these powers out front. I'm just kind of in that expanding and condensing mode. So it gives me 6 ln e minus 2 ln e. Well, your inverse property says ln e. I talked about this. This looks like line. I could put a line through it. So that's like 6 times 1 minus 2 times 1. So 6 minus 2 gives me 4. Cool. No big deal. Let me show you with this one. Maybe again you're in that condensing mode and you're like, okay, well there's a minus sign, so I'm going to rewrite it as division. Then going back to Algebra 1, properties of exponents, you can subtract these when you divide them. When the bases are the same, you subtract the exponents, so you get ln e to the 4. No big deal. You see that and you go, oh wait, ln, that's the inverse property. So I just get a final answer of 4. Notice both of them use expanding and condensing properties, both of them use the inverse property, and both of them gave us an answer of 4. So it's important for you to show your work, be mathematically correct, and we'll all get the same answer. Now the last one, I'm going to pull up some skills from Unit 1. So I'm going to say, okay, first, I'm going to put these two together because I have ln of two things separated by addition. So this would be ln of x plus 2 times x plus 1 equal to ln of 4x plus 14. Now in the previous section in 4.2, we learned the one-to-one property, where if I'm taking ln of two quantities, I can just set those two quantities equal and solve from there. Then I'm like, okay, well, I don't know what to do, but let me go ahead and FOIL or distribute that out. That gives me x squared plus 3x plus 2 equal to 4x plus 14. Now I got a quadratic. So this goes all the way back to Unit 1, solving a quadratic. So I'm going to move everything over to one side. So it gives me x squared minus 1x minus 12 equal to 0. And everyone's favorite, that'll factor. So x squared gives me x and x. The back sign is negative, so they're going to be opposite signs. And what will multiply to give me negative 12 and add to give me negative 1, that's a 4 and a 3. Still struggling with factoring? Shoot me a message. I'll be happy to send you some more resources on that. So I'm just solving this out here. That gives me negative 3 and positive 4. So all of this was Unit 1. Can't forget about that. This came from the previous section, so hopefully you worked with the homework and already figured that out. And then this step here was just new in this section of condensing it down. So I hope this helps with 4.3. Again, if you have any questions along the way, feel free to send me a message. I'll be happy to help you out.